Okay, so I'm going to run through this pretty quickly, but should be helpful to students of all levels of mathematics, and this is very helpful to me. Personally, I've showed this to students before and explained it to them, and they have also found it very helpful, especially on homeworks and things like that. It's just a time saver, and it's reliable. So, we're going to be dealing with simplifying a square root of something itself that is not a square number. So, simplifying n, the square root of n, where n is not some number that has a perfect square root, because it itself is not a perfect square. So, we're going to want to break that, theoretically, into some product of a square number times a non-square number, and then we can separate that, and I didn't show that here, but we can separate that into the square root of a squared times the square root of b. Now, the square root of any number, in this case a squared, is just going to be that number itself, a. And then, of course, the square root of b, if b is not, of course, as it shouldn't be, because we've defined this not to be a square number, itself a square number, then it will just remain as the square root of b. So let's do an example. Let's say 242. Now, the way I like to do this in my calculator is using this method, which makes sense if you think about it, which is that you want to take the number you have and divide it by some number which itself is a perfect square, and whatever your resulted in, whatever you get, I'll say this is b, so this would be a squared, but we use x in the calculator in rectangular form. That'll be your variable, and it will give you some b left when you do the division. If you can find this number, the highest number, x, that leaves the lowest number, b, then you can say that the square root of 242, your number, will equal the non-squared, so the unsquared version of x, just x, times the square root of b. Now I'll show you what I mean by this. So going back to square root of 242, in my calculator here, y1 equals, and we're in rectangular, so mode, function, mode function. And so, as you can see, this is not a perfect square. And I'll go to my table, or my y1 equals, and I'll say I want to take 242 divided by, and I'll make sure to put my parentheses here, my variable in function, in rectangular, x squared. And then I'll make sure that I'll do second window to make sure my table my table starts at the value of x equals 1, and then I'll do second graph to access my table. Now, I can see my table values. I'll zoom in here. I can see my table values. I want to find the smallest number here, which is a whole number, that results in these whole numbers, which are by definition going to be whole numbers, positive, from the way I have my table set up, my table set set up. And so I want to find the smallest number here that corresponds to one of these numbers, because these numbers are, again, of course, going to be squared. Now, at 11 squared, we have 2. So what this means is 242 divided by 11 squared is going to give us 2 left. It's going to go in twice. So this would mean, and I'll zoom back out a bit, move the camera a bit, but let me see. See if I can zoom out. There you go. That I would write this as 11 squared times 2, and I can split this like we did here, and this will give me 11 square root of 2. And that will be my answer. So how do I simplify the square root, again, of 242, which is itself not a perfect square? I divide it. I assume that I can divide it by some other perfect square and get a remainder of a whole number, which I can, in this case. If you cannot, this number cannot be simplified. Whatever you have here, the square root of that will just be written as the square root of that number. So because we can divide it by a perfect square and get a whole number remainder, which we always will if we can divide it by a perfect square, then you'd simply take the number that was squared, so x squared, you simply would put x here, where x was 11, and whatever b is, whatever the division is, you get when you divide, however many times it goes in, you put under the square root. And that will work every time. So I hope that helped, and I'll see you next time.